I've been told that this has to be a lightning talk, even though it's half an hour long, so we'll see what we can do. I'll try and talk very quickly. So I am Tom Myers. I'm one of the senior cloud architects for the Accenture Cloud Platform. Just real briefly, the Accenture Cloud Platform is a tool that we built to allow our giant enterprise clients to be able to take advantage of the cloud in ways that they have requirements around. Large enterprises have requirements around governance, they have requirements around analytics and services that they need to support themselves, multi-cloud billing, lots of things that you can't really cobble together yourself and you really kind of need some help doing. Of course you can, but we assume they don't want to. So we think all enterprises are on a digital journey. Accenture has an initiative called Journey to Cloud right now, and we believe every enterprise that we're helping is on a journey to cloud one way or another. So we built services around cross-provider billing, analytics, governance, and so forth in order to help these enterprises get to where they're going. Now we had challenges in building our own platform, which we've been building out for several years now. We started in a hosting environment, same as most data centers do. We moved from there to Amazon Web Services virtualization, and in the last year or so we've been building out our serverless platform. And now all new functionality that we're building out is going on to that new serverless platform. So the main challenges we faced, obviously speed. We needed to be able to do things very, very quickly. Budget, we needed to do things as cheaply as we possibly could. And then we needed the ability to align ourselves to what the market needed. And the market is changing ever so fast. So a lot of the traditional development, waterfall development styles and things that big companies and even Accenture itself are used to using, they're not very effective when you're trying to keep yourself aligned with the market. And so we faced the same challenges we think that our clients will face, and the same things we've been hearing from those large enterprises. But we need that ability to innovate without disruption, to secure without complexity, to bring value to the enterprise, to deliver without delay, and to operate at scale. And I'm going to quickly go through these slides, I hope, and show you how we are able to achieve those things in ways that we can help enterprises and also that they can do it themselves. So the first thing that we built was our core ring model for how we would build the platform. At the very center of it, ring 0 is where our core services live. This is where we're building APIs, primarily only APIs, some data structures of course, and we do continuous delivery into that environment all the way through to production, and I'll show you how we're able to make that happen in a minute. And this is the very foundation of our platform. And then the applications, the things that most end users will interact with, are at ring 1. So those applications and services then consume the things in ring 0 underneath them. It's very similar to an operating system model where the kernel operates all those services inside, and then you're actually writing code that happens on top. And then at ring 2 is where our clients themselves, our client teams, are able to develop things that then take advantage of the services that we've put underneath them. And so we were instructed to and ended up developing a lot of paranoid security around this. In one of the earlier talks, they said small groups can develop in a single account, but larger enterprises need multiple accounts. So right now we have 10. We just added 3 more for additional sandboxing accounts. And we do our separation for all the security happens by account. So our various rings that I showed you and the various life cycles between them make up most of those. And then we use security built in by design, so everything is code-driven using API Gateway and Lambda. We have code isolation by building into Git repository. I'll show you a little bit about that. We do double peer reviews to make sure that the code development is secure, that we're not introducing things that we shouldn't introduce. We use short-term IAM credentials for builds and access and everything that we do. And then we use some of the secure credential storage that AWS offers you in order to store our client credentials that we need. So we're a broker, so we're provisioning stuff on behalf of the clients that are using our service, so we have to have their credentials in order to do some of that, and we have to make sure that we're not compromising their data as well as compromising our own data that we use. So that ring model was the first thing that we built because it solves that challenge about innovation without disruption. We're able to do continuous delivery into that core, and so what that means, because we use a versioned API model, it means that all the stuff that's built on top of our APIs can continue to function even as we add new functionality into those APIs. And if we need to do something that introduces breaking changes, then we version the API, and so those higher level applications can choose to adopt that whenever they're ready to. And so in that way, we're able to keep pumping out new functionality into the ecosystem, and they're able to consume it when they're ready. And then by using the separation of accounts and the policy-based minimal security access policies that we have, it's a lot less complex than if we were trying to run multiple stacks next to each other and make sure that we were naming things appropriately and not accidentally confusing, one function that's in test with a function that's in dev or something like that. You want to make sure you have enough isolation that you can't hurt yourself accidentally. And so that was the primary bit there. So this is just a very high-level model of how we're implementing things using serverless. It's basically a microservices model. This isn't the real services. This is just essentially a straw man architecture. But I want to point out on this the things that are important to large enterprises, because most of us that want to just go out and sandbox some stuff, we can go build anything we want. It doesn't really matter because we don't have all sorts of ITIL processes and all sorts of corporate requirements lying behind us. But for large enterprises that do have those requirements, you have to have answers for them. So it starts with DNS, the very front door of where you're getting in. The organization is going to own that DNS. They're not going to let you own the URL that you're reaching. They have to control that. So you can't just start making up new URLs when you want to introduce new products. You have to work that through central IT group. But yet, you want to have complete control over the DNS so that you can move things around as you need to. So we have to provision a CNAME from our corporate enterprise every time we want a new top-level domain, and then we subdomain that using Route 53. It's not hard to do, but it does require us to make sure that we don't add new top-level things very often, right? So we have API.something, and we have API.something else, and those things sit at the top of the pile, and www.that thing sits at the top of the pile, but then everything else changes underneath that. We don't try and use a naming convention that would require us to go back to the CIO office every time. The second thing is that we need a global content delivery network, right? A large enterprise is going to be globally distributed. They're not going to be able to say, oh yeah, I'm just hosting this out of an S3 bucket somewhere, hoping for the best on the other side of the world. The beautiful thing about Amazon is that if you use API Gateway and you use a custom domain name in order to support that DNS that I just mentioned, then you get CloudFront for free. You have to get CloudFront every time you use API Gateway. And CloudFront is inherently going to give you that global CDN. So you've already built into it what's going to be an enterprise requirement anyway. Now, some enterprises will still require Akamai or some other solution, but by and large, we found that for our solution, that this is going to work just fine for us. And then we do use S3 buckets to do our hosting, but we put that behind a CloudFront distribution as well. And we use a single page application, I think written in Angular mostly. And that then makes those AJAX or other web calls over to the APIs. So all of that is very fast, very easy to deliver. All of the artifacts are cached very, very quickly at the edge. So we don't have a lot of latency when we start executing what we're doing. In the next bit, right, in the center where we actually do the compute, we're using API Gateway, and then those API gateways are implemented with Lambda functions. Now, there are people who I've been talking to around who say, well, then we chain from one Lambda to another. We don't believe in that very much. We think that if you're going to execute a Lambda, it's going to be done with itself. It's going to gotta use a microservices-style communication to pass its data along to someone else. So we rely on Kinesis streams for the most part, because we find that stream processing works really, really well in this environment. We use SNS in a few situations. We have Redis cache out there for a few other things. And we find that the ability then to spread out your functions in the places where you need to spread them out, where you're getting the traffic, and then they collapse back down sort of automatically when they need to. And then the final section is persistent storage. We use a number of different places to store things, and we ultimately settled on putting the vast majority of our long-term data into Elasticsearch. Thank you. Elasticsearch is really the right place for data that services that you don't know exactly what they're going to want to go get need to go get, because you're able to give really query language type requests and get back the data that you need. It's fast, has very good capacity, but then we also use some transactional data in DynamoDB, where schema is a little bit more important. And then a lot of analytic data goes into Redshift, and we could have that same discussion that the previous speaker had about whether we want Redshift or whether we want Athena. And we're actually still doing some experiments to see whether millions of lines of billing that are already in S3 work better out of Athena or work better being moved in part over to Redshift. So anyway, this is the whole big picture. It's a generic model, but I'll show you a couple of real examples for some of the things that we're doing inside of it. But in that model then, we're able to drive out the ability to see our billing at the compute level, at the function execution level. So it makes it very easy for us, because we have to design billing anyway, right? So it makes it very easy for us to look and see where things are causing problems from a budget perspective, and it allows us to make budget an actual requirement. Cost is a requirement in the design. So we can see things like, normally our function is 4 cents or whatever in a given month, but if it turns up to be $15 in a month, then we have a problem, right? And we can see that very quickly without saying, one of our servers is running hot, and now we have to go dig into it and find out what app on it is running hot, and so forth and so on. So by using the microservices architecture and using the functional architecture in serverless, we're able to very quickly eliminate a bunch of the problems. And then that gets us to that third, I guess, solution, bringing value to the enterprise. We're able to very quickly deliver an as-a-service and a buy-the-drink environment, and it really drives costs down, not only for us, but then we pass that on to our clients as well, because they're only paying for what they're using as well. So the DevOps model in the enterprise is what enables all of this. And so this is a lot of stuff on this slide. I'm not going to go through it, but in order to have an enterprise DevOps model, in order to be able to actually do continuous delivery into your production environment, you have to have a very large amount of agreement across the board amongst a whole bunch of different groups. Your architecture group, your engineering group, your operations group all have to agree on that model and how that's going to work. Your security group has to be involved in there. We do a lot of ITIL processes that revolve around things like release management and assessments of operational readiness. So how on earth can we do that? And the answer is we break up all of the requirements that we have. And Accenture is one of these companies that, years ago, you had a book this thick that had every procedural aspect of what your company was doing written down in it, right? So we know how to break down the process. So we break it down and we say, this bit we can automate. This bit we can get agreement in the front, and so long as we follow the pattern, then we can continue to execute along that pattern. If the pattern changes, then we're going to break the build because it's going to be something new that wasn't in the pattern before. And so as long as we get buy-in throughout the whole process, then we can continue to continuously deliver, and we can use that DevOps model. We use good tools that everyone knows how to use, that are otherwise used elsewhere in the environment, so we're trying not to introduce things other than the serverless components themselves that people generally haven't heard of. And we try and get all the way to the point where we can say things like, if this goes live, and we do testing in live, because we do some testing in live to make sure that what's in live is working properly. If we start seeing breaking changes that we didn't anticipate or somehow missed, we have the ability to then roll that back to a previous release of that version, so that even in production we have that. So all of these things satisfy the operational requirements that the enterprise has. So this is an eye chart, I apologize, but this is a view of our DevOps pipeline. I've broken it into 3 chunks. The top line there is the developer, right? What is the developer doing? He's writing code on his laptop, or she's building out whatever the function is in probably Node.js, some things in Python. We use some of these other tools that you can see there. When we chose how we were going to build out our environment, we had to make 2 choices. We had to be able to build infrastructure, and we had to be able to build functions. So to build the functions, that's pretty easy. You pick Node.js or you don't. But that's what we chose. And in order to build the infrastructure, you can pick a variety of things. When we originally looked at CloudFormation, there were things that it could not do, especially around API gateway, and so we had to look elsewhere. We settled on Terraform because we think Terraform's a very nice solution, and it's cross-provider, right? It works in different providers, works on-prem for some things as well. So when we chose Terraform, there were some things that it couldn't handle, and it's really complicated inside. If you've written an API gateway and tried to specify it out in Terraform, you end up just writing tons and tons and tons of these little indented subroutines, or not subroutines, but attributes and so forth of the objects that you're creating. So we internally developed a platform. It's written in Python, which allows us to use a model-driven specification. So the developer can actually go in and, using a CSV file, create what his model for the various pieces of infrastructure, right, the APIs need to look like, or the DynamoDB tables, or whatever it is that he needs in these different CSV files. And then this big Python script will process that, turn it into the Terraform script that we need. It validates that there are comments in there. It validates, it does linting. It does a number of other things against that code to make sure that we have well-constructed code, and it gives us a single generator that we can then verify is following the procedures that we've gotten everybody to agree on in order for it to be involved in the DevOps pipeline in the first place. So all of that's happening on that top line. Everything gets checked into Bitbucket that we use. We have internal Bitbucket. When it gets checked into your code branch, we require developers to have 2 different pull requests so that their code is double reviewed. And it's only after those 2 pull requests are done that it can be merged back into the master. When it's merged back into the master, then that triggers the Jenkins pipeline, which is on the next line down. Jenkins checks out the code, it rebuilds, it does all the things that it needs to do, and then it sends it through essentially the same tooling set. So the developer has on their laptop the tools that they are going to expect their code to go through when it goes through the Jenkins pipeline. Jenkins controls then all the different environments, and so it will attempt to push to dev, it will attempt to push to test, it will attempt to push to stage, it will attempt to push to production. Now, we can control whether or not we're allowing that particular functionality to be being pushed to whichever environment we want it to be. But once we turn it on, we don't generally ever turn it back off, but we make sure that the testing is appropriate for each of the stages. So in the development stage, we may not break your build in dev because your documentation isn't in place, but we probably won't let you build in test if your documentation isn't in place, if you don't have the release notes, if you haven't done the communications, if you don't have a sign-off on some new serverless feature that you're using that's not in the whitelist anymore. When we go lint your code and all of a sudden you're using something that's not approved, you may fail out of test, even though we may allow you to build in dev. Then that goes, there's a fork there because our UI takes a slightly different path than our back-end systems choose, but by and large this is the same for our Angular code that we're doing in our UI as it is for the Node.js and the Terraform that we're doing in the back-end. And then finally, when everything goes into production, we have sort of a 2-pronged approach. We do some external testing. We deploy some different tools that can do pen testing and do all sorts of different kinds of testing against that environment. But then we also have our own internal monitoring, some of which is based off of CloudWatch, and some of it is our own. CloudWatch understands a lot about what's going on at the hypervisor level or at the functional service level, but they don't know things about your transactions that we need to know because we're a multi-tenant SaaS environment, so we need to know what client that transaction was being executed on behalf of. We need to be able to surface that information in our monitoring. Some of our stuff will communicate with a back-end ITSM system, ServiceNow or something at the client site. Well, we don't want to report that the functionality for the whole system is down because that client's ServiceNow operation is down. So we need to be able to know on a client-by-client basis what the system health is, and so forth like that. And then that goes through to our operations team, and our operations team will get automated notifications of alerts and alarms. That actually will raise tickets in our own internal ITSM system. So our service desk will get an alert, and that'll form a ticket. They'll then, incident management will go through its ITIL process. It'll get pushed through and eventually gets back into our Jira system as a bug fix or whatever it may need to be. So that ability to then to have that operations model going there, the DevOps model, focusing on the dev side of it for right now, allows us to have that delivery constantly into production. and allows us to do that innovation and get it out the door without having to wait for approvals that are essentially for the same thing that you've already had approved before, right? If you need to, a manager doesn't have to sign off to say that yes, you can put a new version of the API out there unless that new version of the API is using new technologies that we haven't had approved before. This is our operation and monitoring loosely. It's when we publish any new Lambda function, we have a second Lambda function that sits out there watching, and when a new Lambda function gets pushed, we take its logs, because all Lambda functions log, and we take its logs and assign them to a log group, and then that log group is subscribed to a Kinesis stream. So all of our logs from anything that we've published through the pipeline begin flowing into Kinesis, and then from Kinesis, we do two things with them. We take a Lambda and push that into Elasticsearch, and then we can, through Kibana, our operations team can go in and can see those logs. And then we also push it a second way down where we go into our own alerting and metric system. So we parse logs, we pull events out of those logs, we pull metrics out of those logs. That gets stored in Dynamo. And then we have a separate API in front of that so that we can hook up a dashboard down there in the front corner. So we have operational health dashboard that can tell us how things are functioning. And so we, the little humans that you see on here, are mostly our operational team. Some of it's DevOps team themselves, right? We're a big company and we've been around a long time, so we didn't magically grow a beautiful, perfectly implemented DevOps organization, but we have a lot of operations people who are learning the dev side of it so that they understand what it takes to be able to make changes in the system, because they can't go in and fix the way they're used to going in and fix, right? Everything's code now that has to be fixed. You can't go tweak infrastructure in a console or something. Meanwhile, on the other side of the fence, all our developers are having to learn that there's operational responsibilities that they have and that they have to have some ownership over that operation. So it's slowly moving together in the middle of the night. And then we have other Lambdas out there that age out our metrics, because some metric, it's nice to know that you had a problem, but it's nice to know that problem's gone away as well. And then we have that goes through an alerting system, so we can use SNS to then subscribe whatever sorts of pushed out alerts we need. Our clients can subscribe to those directly if they want to, and so forth. So that ability to operate at scale gives us this final challenge that we are looking at, and it also allows us to align with the operating model of the target enterprise. In our case, us. But in the case of our clients, we can align with their ITSM systems. We can push service requests and change requests through to their systems using things like our discovery process, which discovers their estate out in the cloud, and then it can detect changes and pass that through to them. So here are some patterns. I'm running out of my time, so read them very quickly, but most of this makes sense to people who've been listening to conversations today and the ones you'll listen to tomorrow. I think probably the most important one on there I buried in there, which is think about security right away at the very beginning. Don't think about trying to add security into your system later. And then these were the three challenges I put up at the very beginning. I said we needed speed, so we created an architecture that allows third parties to add in stuff. It allows us to work at different speeds. We can have waterfall development next to agile development if we need it to. And in the very core, we're doing continuous delivery. We have a budget that tunes all the way down to 0 and all the way up to whatever it needs to be. And yes, we've had to call Amazon and make sure they raised our limits in about 12 different places so that we can actually speed up to what we need to speed up to. And then finally, that commercial alignment to your market needs. We're able to now, because we can dial things up and down, we can turn that around and give that to our clients. And because we can pivot relatively quickly on what we're offering, we can turn very quickly and give them something that they need. So, last week they needed to be able to provision servers and watch their servers. And many of them still need that this week, but they also now, maybe they want to put together a blueprint of a serverless platform that they want to put out there. Well, we need to be able to support that, and so we can support that through discovery and through our billing. So that's all I have. If you have questions for me, I was going to give you these 30 seconds, but I'll take them back. I will be out at the party, and Accenture has a little table, and you can try and find me at that table, or you can find other people, and that's what I have. Thank you very much for listening.